All right, ladies and gentlemen, let's try this again with set 59. We're going to see writing equations from 2 points. We're going to talk about them on the graph. We're going to see simultaneous equations with fractions and decimals. And then we're going to go from rectangular form to polar form. Okay, so we are going to write equations from 2 points. But to do that, they give us a graph with data on it. We have to draw what's called a line of best fit. So you'll see that here in the blue. See how the line fits my data, and I say fits in quotation marks because it looks like the shape of the data. It follows the pattern. If I had something that looked like this, or I had something that looked like this, neither of them, quote unquote, fit my data. So the blue line is my best fit for my data. Now notice, my blue line does not go through any of those little X's. So to find my 2 points, I'm actually going to create 2 points. And that's where these dotted lines come in. See how my line crosses through the grid points right there? So that is going to be one of my ordered pairs. So I'm over 148 and I'm up 52. So I'm going to actually create a point there. Notice it is a point on the line, not a point near the line, not a point that's not close to the line. I'm picking something that's on the line. Then I'm going to look for another place where I see that they cross through my grid lines, or so I'm going to go with this one here. So I'm over at 153 and I'm up at 60. So I just followed my dot down and over. So I actually am choosing 2 points that are not points of data, but are points my line goes through. Then from there, you know how to do it. You're going to write an equation from these 2 points. The hardest part is just creating those 2 points. So if we look here, my line is going to be a line of best fit. It fits my data, which is scatter plot. Typically, when you draw on a line of best fit, I like to tell students have about half your data points above your line and half the data points below. That does not mean draw a line like this where half are above and half are below. Remember, it consistently needs to fit my data. Then you're going to look through for points that are on the line, or you're going to create points, okay? So here I'm going to make points down here. It doesn't exactly go through, but it goes through really closely. Okay, and then I'm going to pick probably like this point. And now it's not on a line, so I have to use approximates. About 1.75 and about 3.75. So notice when you're creating these 2 points, you might have to use some flexibility with it. Now everyone is going to pick two different points from each other. Very rarely will you come across that you and your neighbor have the exact same 2 points. So lines of best fit, and these equations are going to be um, not exactly the same for everybody's. But when I go through and grade these, especially on your test, I'm going to look for your data, your line, I'm going to look for your points, I'm going to look for your support as to why your equation works. But our equations should be very similar. So then you just go ahead and you solve and by writing the equation with 2 points. Okay, so the next thing we're going to look at is equations, simultaneous equations or systems that have fractions and decimals. So the easiest thing with this is let's just go ahead and make them into whole numbers. Okay, so to make my fractions, I have a denominator of 8 and I have a denominator of 4. So I'm just going to, just like I would in any of my other algebra problems where I want to get rid of the denominator, I'm going to multiply by the least common multiple. Every single stinking part of that gets multiplied through. So I get 3x minus 2y equals negative 16. Now I'm dealing with just whole numbers. Makes it a lot nicer. In my denominator here, or my not denominator, my second fraction, or second equation, I'm going to look at my decimals, and I want to make them into whole numbers, okay? So I see that my second fraction has some things that go out to the thousandths place. So I'm going to multiply everything through by 1,000. So now when I multiply everything by 1,000, I'm going to get 12x plus my 0.02 times 1,000. I'm going to get 20 y equals, I have my 4.496, it's going to be 496. Now, when you have a decimal, you're not always going to multiply by 1,000. You're going to multiply by 10, 100, 1,000, whatever is going to get rid of those decimals. Now, I'm just dealing with back to my same old, I have all whole numbers. I can use substitution. I can use elimination. Either way, my personal choice with this one, I would look at, I have a positive y and a negative y. So I'd multiply this one by 10. So I'd get 30x minus 20y equals negative 160. Now see how my y terms are opposite, and they're going to cancel. Okay, so you can just go ahead and finish solving that. So nothing new, just things we're going to work the other direction from. So now we're going to convert something in rectangular form to polar form. So we need to come up with what does this picture look like? Our answer is going to be blank and then something inside there. So I'm going to go back to drawing a picture. I go -4. Okay, that's -4. I'm going to go down 6. So now my triangle looks like this with 4 and 6. We're going to come up with what theta is. We're going to come up with what x is. This is a right triangle. So let's go ahead and find x. 4 squared plus 6 squared equals x squared. 16 plus 36 equals x squared. 16 plus 36, 52 equals x squared. Take the square root on both sides. X equals, I can take out a 4, and that'll be times 13. So the square root of 4, I get a 2 on the outside and a 13 underneath. Okay, so we found part of it. This is going to be our outside part. Now we need to come up with our theta. So let's use, now we have the adjacent and we have the opposite. Okay, so what trig function uses opposite and adjacent? That's my tangent. Tangent of theta equals opposite over adjacent. This is one of those where I'm looking for the angle. Okay, so I have to use inverse tangent. Those will cancel. So I have theta equals the inverse tangent of 6 over 4. So I'm just going to type that into my calculator here. So then I have theta equals, and here 56.31. But now remember, that's my theta just for this triangle. But I actually have to keep in mind that I went all the way around. So I have to add 180 to that. So add 180 because it's gone all the way around. So I have 236.31. So now to write my final answer. So I have 2 square root of 13 on the outside, and then my degrees, 236.31 degrees. Now it is in our polar form. So we went from rectangle, and we drew the picture. We used Pythagorean theorem. We had to use an inverse tangent for this one, and then we found our angle. But remember, we had to add the 180 because it went almost 3/4 the way around. So just a couple of problems here to skip. And again, these were based off of 56 and 57, which we skipped.